Let's start with quadratic equations. Quadratic equations, how we define quadratic equations? Any equation with highest degree of freedom or highest degree as 2. Okay, so like we have ax square plus bx plus c equals to 0. This is the quadratic equation. Ax square plus c is equals to 0. This is also quadratic equation because we have degree as 2, highest degree as 2. Okay, now but if you have only bx plus c is 0, this is not a quadratic equation because highest degree in this case will be 1. Okay, now also if you have ax cube plus bx square plus cx is equals to 0, this is also not a quadratic equation because highest degree will be 3 in this case. Okay, or if you have ax cube plus bx is equals to 0, there is no degree. That doesn't mean that there is not quadratic, but the highest degree is x cube. That's why this is not a quadratic equation. Okay, same degrees, same reason. Highest degree is 3. Now we'll move on to some theory part. The point is, let's say we have a quadratic equation written as this, a general quadratic equation, and where a is not equals to 0, of course, because if a is equals to 0, then it will be a linear equation. Okay, for this, x is equals to minus b plus minus root of b square minus 4ac b square minus 4ac upon 2a. This is a root. These are the two roots of this equation. Okay, these are the roots of the original quadratic equation. Again, where d is equals to b square minus 4ac, the part in the square root. Okay, square root function. The part in this square root function is d, which is also called discriminant. From now on, I'm just going to call it discriminant. Okay, now if alpha and beta are roots, okay, one will be plus and one will be minus. Okay, so if alpha and beta are roots of the given equation, let's say ax square plus bx plus c is equals to 0 is this equation, then alpha plus beta will be equals to minus b by a. That is, sum of the roots will be equal to minus b by a. B is the coefficient of x in quadratic equation. A is the coefficient of x square. Okay, just keep that in mind. Now alpha plus beta is this minus b by a, and alpha into beta, that will be c by a. C is the constant term in this equation. A is the coefficient of x square in this term, in this equation. Okay, one more point about this is alpha minus beta, mod of alpha minus beta, that will be root of d. D is what? Discriminant upon mod a. Okay, or it can be written as b square minus 4ac upon mod a. Do remember this thing, mod a. Okay, this is important. Now let's just draw a tree, a diagram about quadratic equations. We will start, then we'll go in two directions. First, if d is equals to 0. Second, if d is not equal to 0. The condition where d is equals to 0 is, this implies alpha is equals to beta is equals to minus b by 2a. That means d equals to 0 means b square minus 4ac is equals to 0. That is, b square is equals to 4ac. That is, c is equals to minus b by 2a. Mod of b by 2a, that will be minus b by 2a because alpha is equals to beta. Okay, so this is the relation in alpha and beta if d is equals to 0. If d is not equals to 0, roots are unequal. In case d is equals to 0, roots are equal. You can see it here. Roots are unequal in this case. Now again we move on from this. if d is not equals to 0, then also we have two cases. One is this, one is this. First one is a, b, c belong to R, okay, and d is less than 0. If d is not equals to 0, then it must be negative, or a, b, c belongs to R and d is greater than 0. Okay, there are two cases. Now, in this case, when d is less than 0, roots are imaginary. Okay, you can see it in complex number, of course. When d is 0, d is less than 0, you cannot calculate the root of some negative quantity and you have to move to complex number. So that's why roots are imaginary. For d equals to 0, of course, roots will be real. Roots are real quantities. Then again, if roots are real, then what is the relation between them? So again, you have two things coming on. First will be A, B, C. They belongs to rational. They are rational, and D is a perfect square. That is root of something. There is x square. That is a perfect square. Then again, another case will be A, B, C belongs to Q, and D is not a perfect square. Okay. When D is a perfect square, when this is satisfied, then we have roots as rational. Okay, because that will be minus b plus minus root of x square. Let's say x is the term upon 2a. So this will give you mod x, or x in this case. So minus b plus x upon 2a and minus b minus x. Minus b plus x and minus b minus x upon 2a. Okay. If this is the condition, that then we have roots as irrational. Now this is important to note, because if d is not a perfect square, then inside root there is not a perfect square. That's why some root of something will come out, and root of 2 or 3 or something like that. So not exactly these, but anything may come up, but that will be a root and not a perfect square, and so that's roots are irrational, so that root will be irrational. Okay, now we'll move on to our condition. Let's write that. A common root condition. Okay, you have to remember it like this. In JEE, you will be just asked that to have a common root, what condition that these quadratic equation must satisfy. Okay, or what conditions to the coefficients must satisfy. So first condition, for a1 x square plus b1 x plus c1 is equals to 0, and a2 x square plus b2 x plus c2 is equals to 0, to have, for these two equations to have a common root, a root in common, they must satisfy, let's say alpha is the common root, alpha will be equals to c1 a2 minus c2 a1. You have to take the signs in here. Okay, there is no modulus involved. a1 b2 minus a2 b1, and this is also equals to b1 c1, and there will be b2 c1. Okay, oh I'm sorry, this is not c1, this will be c2, of course. b1 c2 minus b2 c1 upon c1 a2 minus c2 a1. Okay, so these are the conditions you can calculate it from. c1, okay, a2, I'm sorry, a2 is not here, a2 minus c2, okay, this will be here, and a1, that will be here. So you have to just think of c1, then a2, then c2, then a1, and you have to just multiply them and subtract them from each other, and you have to divide it by a1 b2 minus a2 b1. Okay, and you will get the common root. Okay, then next point is, for both roots to be common, the second condition is, first condition is this, second condition is A1 upon A2 is equals to B1 upon B2 is equals to C1 upon C2 is equals to K, some constant K. Okay, K is some constant. So this condition must be satisfied that the ratio of the coefficient of x square, x and the common quantity, the respective ratios, they are equals to some constant. Okay, let's move on to other point, next point. That is, let's say fx, our quadratic equation is ax square plus bx plus c, that is equals to 0, and we have our discriminant d as b square minus 4ac. Okay, now first condition, if a is greater than 0, if a is greater than 0 and d is also greater than 0. Okay, so in this case there will be real roots because d is greater than 0. We have seen the tree. A is greater than 0, that means we have positive coefficient of x square. Then the graph will be concave upwards. Okay, you have to remember this. Let's say you have to just remember the graph of x square. The graph of x square is this. Okay, and the graph of minus x square is this. This is for x square, this is for minus x square. So if you have the negative coefficient, it will be concave downwards, and if you have positive coefficient, it will be concave upwards. Okay, this is the thing. So if a is greater than 0, then this will be the graph of concaving upwards. Okay, or opening upwards. And d is greater than 0, that means it has real roots. The roots lie on x-axis, so it will cut the x-axis, and two different roots will be there. So let's just draw this. This is the graph. Now let's say this point is alpha comma 0, this is beta comma 0. Of course they are on x-axis, so the y coefficient will be 0. We have two roots, alpha comma 0 and beta comma 0, and this point here, it will be minus b upon 2a, of course, and minus d upon 2a. Fine, upon 4a, sorry, d upon 4a, that will be. And this is the graph for f of x. Okay, next point we are going to do is, if a is greater than 0 and d is equals to 0. Now in this case, the graph will be, I am drawing it with the blue pen. Okay, let's say this is our, if d is equals to 0 and roots are same, alpha will be equal to beta equal to minus b by 2a. Okay, so this point is minus b by 2a comma 0. Fine, and or you can say alpha comma 0 or beta comma 0, and fx will be like this, touching the x-axis at that point only. Okay, in this case it was intersecting at two different points because we had two different roots. Okay, real roots. In this case we have only one root common, and that's why this is the point where on x-axis where the graph of fx touches. Okay, let me just produce this line this much, and we'll see the third case. That is, our third case is if a is greater than 0 and what is left, d is greater than 0 is covered, t is equals to 0 is covered, so d is less than 0, then we would have no roots. Okay, in that case the graph will look like, let's say this. It is not cutting the x-axis at any point. Okay, you can drop this off, this thing and this thing. We have extended the graph. Okay, so this is our fx. It is not touching the x-axis at any point. Okay, so that's why it has no real roots. This fx has no real roots. Let's say f3x. Okay, this is f2x and this is f1x. f1x has two real roots, different roots. f2x has two roots but same roots. Okay, common root. And f3x is no roots. Okay, and for if you have a less than 0, in that case, let's say if a is less than 0, then d doesn't matter. D, we will have three cases again, and all these graphs will be inverted graphs. Okay, you have to just, if you have this graph, then you have to just invert it. Okay, if you have this case, then you will have this case. If you have this case, then you will have this case, only touching at one point but gets inverted. Okay, inverted graphs. Next point we are going to discuss is location of roots. This is very important considering IIT JEE. Location of roots. That where are we locating the roots? So the first point about this is both roots of fx is equals to 0 are greater than a fixed number, let's say k. Okay, for this conditions are d is greater than equals to 0, first of all, because we have two roots. So both roots, we are talking about two roots, so it can be d is greater than 0 or d is equals to 0. In that case also we have two different roots but same roots. Okay, two roots but they are same. Okay, not different. Then a of f of k, okay, is greater than 0, not equal to 0. It is greater than 0 and k is less than minus b by 2a. Why are these conditions? We are following these conditions because let's draw the graph. Okay, let's say we have this, we have a k point here, and let's say we have the graph like this. So we have 2 points, one is here, one is here. What are the points? This will be, we are saying k is less than minus b by 2a. So let's say minus b by 2a, okay, and plus minus whatever, plus minus d by 2a. These are the two roots. Okay, so let's say this is minus, this will be the minus one and this will be the plus one. Okay, when we add these two, then we'll get this root, and when we subtract these roots, these two terms, when we'll get then a negative. So negative as in you are using the negative sign. So we have two roots and both of them will be greater than. So if the lower limit is greater than k, which we are showing you here, then these two roots will be greater than, both roots are greater than a fixed number k. We have the condition here. And one more condition, a of fk is 0. F of k is this and this graph. So let's say f of k is this one. This will be f of k on this axis. If we produce it, this will be f of k. Okay, this point, this length will be f of k. A into this f of k, okay, this will be greater than 0, which we can see here. Okay, so these are the two conditions for both roots to be greater than k, a number k. Now this can be shifted to a different section. Let's draw it. Root k must lie between two roots. Okay, so k will be less than, k will be greater than minus b by 2a minus d by 2a, and it will be less than minus b by 2a plus d by 2a. This must be the condition it should follow, because these two roots are, this one is this root and this one is this root. Okay, comma 0. So k must lie between, the k quantity must lie between these two. This is the condition. Again, a of k is greater than 0 because this is the same graph as this. Okay, and d is also greater than equals to 0. Similarly, you can find for k to be greater than both, then k will be greater than minus b by 2a plus d by 2a. Okay, because this point is this, minus b by 2a plus d by 2a. And if k is greater than these two, then this will be greater than both of the roots. Okay, or you can say both roots will be less than this quantity k comma 0. Okay, now next point here will be the maximum number of positive real roots. The maximum number of positive real roots of a polynomial equation, let's say of a polynomial equation fx, let's say it's a fx is equals to, let's say, a naught x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus dash 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 plus a n minus 1 x plus, let's say, a n is equals to 0. We have this polynomial equation is, let's say this is the number of changes of the signs of coefficients. What are the coefficients? A naught, a1, a2, an minus 1, an, all of them. Okay. Coefficients from what will be the changes of signs, positive and negative. So positive to negative and negative to positive, negative to positive. Okay. So the maximum number of possible positive real roots of a polynomial equation is the number of changes in the sign of the sign of coefficient from positive to negative or negative to positive. So let's see one example. Let's say we have x cube plus 3x square plus 7x minus 11 is equals to 0. So positive root almost 1, because this is plus sign, then this is plus sign, this is plus sign, this is minus sign. There is only one change from positive to negative. This is from positive to positive. This is also from positive to positive. There is only one change. So we have one positive, what positive? Root. Okay. At most. This is at most condition. Okay. You may have this as minus, then you will have one plus minus minus plus plus minus. 3 positive roots at most. And of course you can have at most 3 positive roots, because the freedom, that is the degree of this equation, is 3. So you will have 3 roots only. Now, next point, if you have any equation to solve any equation, if you have any equation in the form of this equation, let's say x minus a to the power 2n plus x minus b to the power 2n is equals to some constant, where n belongs to z plus, that means positive integers. Then you have to put you have to take another variable, which is x minus a plus b by 2, and put it in this equation and then solve this equation. Okay, then you will get the answers. So this was all about quadratic equations. If you have any, let me just tell you example for this. If you have x minus, let's say 8 to the power, let's say we can have 4, or okay, let's say we have 4 plus x minus 3 to the power 2 is equals to 5. To solve these equations, we have a and b as 8, or let's say this is 4, not 3. This is 4. This will become easier for you now. Okay, this one is 4. So a is minus 8, a is 8 and b is 4. So a plus b by 2 will be 8 plus 4 by 2, that is 6. So you will take y is equals to x minus 6, and then you will put it in this equation. So then you will get a common factor, and then you can solve this equation easily. Okay. So this was all about quadratic equations. Next we are going to solve, we are going to take matrices and determinants.